To pump water from the ground, the windmill reaches to the sky. The blades catch the breeze and spin, while gears convert the spinning action into pumping action. This technology has been around for over 2,000 years. The first known water pumping windmills originated in Persia around 7 AD. In 19th century America, this was the wheel of progress. A metal-bladed windmill that turned with greater force than traditional wooden ones, even in low wind conditions. Its superior pumping capacity made it indispensable to pioneers settling inland, away from rivers and streams. Today, this same design continues to be part of the rural landscape, especially where there's no electricity to run water pumps. Production begins with a 100-ton punch press. Once activated, it cuts triangular shapes from galvanized steel sheets, each with a slot in the center. Each cutout will be a windmill sail. They'll need 18 for each wind wheel. Once stacked, they transfer the sail shapes to a rolling station. The roller curls the steel to an exact curvature, producing a slightly bowed shape, which will efficiently capture the wind. Next, a worker wraps a metal rib around each sail. He taps the sides until it fits snugly to the sail. The rib has a tab that slots into the hole in the sail's center, allowing the two parts to interlock. Bands fit through the ribs to assemble the sails in groups of 3. Next, a worker slides a metal loop over the guide wheel and drives the ends into holes in the gearbox using a sledgehammer. He rivets the ends to the gearbox so that they're solidly ensconced. Next, he inserts the windwheel hub and shaft into the main frame of the gearbox. He taps it to nudge it tightly into place. He then grinds the brake lever to shape it to the brake mechanism on the hub. This braking system is critical. It will stop the windwheel from spinning out of control in high winds. He spins the hub and activates the brake several times to confirm that his machining is dead on and that the brake system works perfectly. If it doesn't, he makes adjustments. Next, using a very toothy circular cutter, he carves grooves into steel blanks to shape the gears. The difference is quite obvious. He installs a set of these gears at the base of the metal loop and secures them with a metal pin. He checks their turning radius, and then mates a larger set of gears to the smaller ones, ensuring that the teeth intermesh. This very substantial gear system will drive the guide wheel, creating the pumping action. Two metal parts called pitman arms link the gears to the guide wheel. A steel pin holds everything together. As the gears turn, the guide wheel rolls up and down the loop to complete a pumping cycle. Next, he screws a series of thin metal rods to the hub. They're called wheel arms, and they hold the windmill sails. The wheel arms fit into pre-cut holes in the structure of the sail sections. He secures the assembly with nuts. Once all the sail sections have been mounted to the wheel arms, the windmill is ready for a spin. It's a test run to confirm the wind wheel and gears function flawlessly. It takes a crane to lift the 290-kilogram windmill to the top of its tower. Once it's in position, a worker guides the gearbox onto the mast pipe. When it's secure, they hoist the helmet. It's a cone-shaped metal cap that will protect the gears from the elements. He bolts it to the top of the gearbox. With that job done, this windmill is ready to pump. It should last decades, providing water that is as free as the wind.